Find an equation of a plane through the point P, which is orthogonal to the line L. P is a point on the plane. L is a line perpendicular to the plane. So our plane is, say, this plane. Let's call it A. To write down the equation of A, we know the point on A, and we also know the normal vectors of A. So the normal vector of A we can choose to be a point on A, which is P, and the normal vector N can be chosen as the direction vector of L. And the direction vector of L can be obtained from the equation of L, which is a coefficient of the parameter. So in our case, the direction vectors say V is -4, -1, -5, and the normal vector can be chosen to be V, which is -4, -1, -5. So you have enough data to write down the equation of A. So recall that if we know a point P, say x0, y0, z0 on A, and we know the normal vector N, the normal vector of A, and say the normal vector of A is a vector ABC. Okay, and any point Q on the plane A, say, has a coordinates x, y, z on A, vector PQ is perpendicular to the normal vector. This means that the dot product is 0. PQ dot N is 0. In this case, PQ is vectors x minus x0, y minus y0, z minus z0, dot product with vector ABC. Zero. This gives us the equation of the plane AX x0 plus B y minus y0 C z z0. Okay, so that is a general formula for the equation of the plane A. Okay, in our case, is P is this point, N is this vector. Therefore, an equation for the plane A is -4 x plus 2 minus 1 y plus 5 minus 5 z plus 5 is 0.